equal numbers of men and women claims it emits equal numbers. So the claim is 0.5 or 50%. Would you agree that's the claim? 50% men, 50% women. A random sample of 500 students gave 267 men. At the 5% level of significance. Now, do you know what 5% level of significance means? It basically means either side. There's 2.5 this way and there's 2.5. But you're still talking about the 95% confidence margin that we did in the previous exercise. Is that all right? Just a different way of asking the same question. Is that all right? Now, is there evidence to suggest that the college is not evenly divided between men and women? This is what we call a hypothesis test question. In a hypothesis test question, what happens is one of them states, so they'll make a claim, then we'll do a questionnaire or sample, and we have to prove that whether their claim is true or false. This is called hypothesis testing, right? And you do what's called, there's 4 steps to this process. Here's step 1. H0 is called the null hypothesis. Okay? Now, null hypothesis means accept their claim. The claim is true. Okay? So what we're going to write down? H0 is the college admits equal numbers. That's what the claim, doesn't it? Is that right? The college admits equal numbers is what they're claiming. Now, we do H1, which is called the alternate hypothesis. What's the opposite of the college admitting equal numbers? The college doesn't admit equal numbers. So, okay, this thing's worth a lot of marks and it's just wordy. Okay, so it's always one of them is what they claim, and then the one that you write the second one is the claim they said is not true. Now, step 2, we're going to do the confidence margin. Okay, so we're going to do what's called the sample proportion. Does anybody remember what the sample proportion is? How many people did we interview again? Out of those 500, how many of them were men? 267. This goes in evenly, so I think it's what's it? 0.534. So we don't need to use the fraction because the decimal goes in nicely. All right. Now, next thing is margin of error. Okay, and I'm not going to be using 1 over root n. I'm not going to use that like the book does. Okay, I'm going to be using the 1.96 p value. Okay, so just remember that for tonight's homework. You're going to be using the 1.96 delta p, which is 1.96 square root of p 1 minus p all over n. Okay, I can probably rub this out slightly now. What do we put this as? 0.534, yeah. And will somebody take 0.534 away from 1? 0.466. Okay, and then your n value. How many people did we interview? 500. Okay. Now, so step 3 is getting your margin of error. Okay. So what is the margin of error? Just give it to me to whatever decimals you can. Is it 0.044? Okay. Perfect. Now, oddly enough, the 1 over root n answer was actually 0.0447. There wasn't actually much between them. When the n value gets bigger, the 1 over root n actually becomes reasonably accurate. But once again, we're not risking that. We're using the 1.96 delta p version. Okay. Now, next thing we're going to do is construct the confidence interval. So this is step 4. Step 3 was margin of error. And step 4 is confidence, 95% confidence interval. Okay. Now, what do? We get our 0.534, and what do? We add on 0.044, and we also take away 0.044. What do we get? 0.49. And then the other one? 0.58? 0.578, right? Doesn't, yeah, 0.58. All right. Now, what was our claim again? The college emits 50%, isn't it? So, what you know is about our interval? Does it contain 50%? Because the interval contains 0.5, which is 50%, we must accept the null hypothesis. You can also say we must accept H0, that the school admits equal numbers. Is that okay with you guys? Okay, guys. Now, let's start off. H0, what do we reckon? Yeah, I'm gonna be quite lazy here. I'm just gonna do this. That's pretty lazy, but you get the gist, right? I'm just reusing the question to, yeah. Is that right? Cool. See the word have? I can put in do not have for the alternate one, can't I? Because I can reword it like that. Do not have, yeah. So you can word that any way you want. What would be another way of saying it? That like less than 60% of its readers have third level degrees. Like that's the opposite as well, isn't it? But I'm going to try and reuse the language here as much as I can, okay? So all I'm going to do is going to grab this, Control D it, and then I'm just going to write in here, do not have third level degrees. Is that all right? Everybody see how I adjusted that? Okay, nextly, we're going to go, that's part 1. Now, what's part 2 again? 208 divided by 312. What do we get? Is it 2/3? 2/3 exactly. Be careful with that because that's 0.6 reoccurring then, is it? No, it's not 0.6. That's a big error there, right? So let's leave that as 2/3. I'm not rounding off anything. Is that all right? Now, part 3 is margin of error. Okay, so let's do this. It's 1.96 square root. Now, it's p times 1 minus p, isn't it? So that'll be 2/3. And then what's 1 take away 2/3? 1/3. And our n value? 312, yeah? Okay. You want to put all that into the calculator? Or some of you might already have it. Do you have it? What you get? Is that okay with you guys? 0.523. Okay. 4. 95% confidence interval. Okay. So what do we see here? So it's going to be 2/3. It's going to be 2/3 plus this, and also 2/3 minus this number. Do you have both those numbers already? What you get? 0.614, yeah. 0.718. Okay, lads, is 60% present in this interval? No. Oh, at least. So that means actually, yeah, we're above it, aren't we? So actually, the claim is true, isn't it? That wording is very important. At least means anything over 60 justifies the claim. If it says is exactly 60%, then we'd reject it. But yeah, that wording is very, very, very important. Okay, so here's what they have in the. I have two ways of saying this. I'll show you one way. Because the confidence interval is all above 60%. We must accept H0, the claim that over 60% of its readers have a third level degree. Is that all right? What it's claiming is that the p-value is 0.36. Would you agree with that? And also it's claiming is the error, which is 1.96 p 1 minus p over n. It's claiming that that equals 2%. So also I want you guys to do is what you did at the end of the last exercise. What you're going to do is you're going to fill out the formula. And then you're going to square everything and find the n value for me when you're ready. Right? All right. So bring the 1.96 underneath. Square both sides. And that essentially gets rid of the squared sign, doesn't it? That's how far I'm along now. The n, which is currently division on the bottom, turns to multiplication on the right hand side. This whole thing, let's see what I have to do there. Sorry, I'll do this bit slicker than I did there. That's where we were at, wasn't it? Yeah. And then what we're going to do is we're going to drag the full thing underneath. And then we're going to put that into the calculator. And what you all say we got? 2,212. Is that right? Point what? 0.7. So I'll go 212, 213 really. Yeah.